let me first show you how, like, just picking up where Marcos left, which is, looking at the cost and service levels as a summary view, and then we'll get into detailed network design of how to build these models. So as you saw, like, this is what the costs look like, across different scenarios. Similarly, once you build different models, you can compare this different scenarios in OptiFlow tool, which is your total cost, and that can be broken down into cost heads, like transportation cost from on the first and the middle mile, supplier to warehouse or plant to warehouse, and warehouse to warehouse. For example, hubs was warehouse to warehouse, and then warehouse to customer. So this is just a view and of how you make these comparisons. And now let's get into how do we start modeling these tools. So first, I'll start that how you could use these software itself. So in this platform, or for that matter, any supply chain design software model platform, you start with creating a baseline model. So that's step one. And to create these models, typically we once we have model is created, we start analyzing the transportation data, the order data. So a supply chain is a function of how the product is flowing, where are the nodes, what SKUs, what are the costs. So it's really a digital twin of your physical supply chain. But for any mathematical model to be trusted, first we need to create a model which mimics your supply chain in terms of actual KPI, which is cost and service. That's why we create baseline, which does nothing, but it just replicates your historicals. So in this historical flow, you can see, what was the products. For simplicity, we are just, we aggregated all product into single product. But for large models, you can create SKU level models, which can be 10,000, 20,000 SKUs, even higher. Then for customers, we aggregate more customers typically to 3-zip or 5-zip levels. For US, there are 40,000 5-zip levels and about 1,000 to 1,500 3-zip levels. So for the sake of simplicity, we recommend aggregating the customer data. Then you can create the demand, which could be number of packages, number of units, depending on how the supply chain is existing. You can load in your supplier information if you're not a manufacturer, and you're a drop shipper or just procuring goods from suppliers, or you can load in your manufacturing information, the work centers, and you can make complex models as well. But since this is focused on fulfillment distribution, so we'll focus more on that side. So you can start layering your inventory holding nodes, which are really your warehouses, and the cross-docks, which are your parcel hubs, to deliver the entire customer. So you can load the locations, their capacity, so on and so forth. And the two differentiator for OptiFlow compared to other supply chain design softwares on the market is our ability to quickly load parcel rate contracts. So parcel rate contracts are very complex compared to truckload, less than truckload. They are done at zones level. So there are zones. There are different service levels. 1 day, 2 day. 1 day is priority, standard, overnight. Then there's domestic 2 day. There's express saver. And then there is ground and smart post. So there are a bunch of different things, but you can load all these contracts very easily, including surcharges, and that makes modeling very easy for these kind of network analytics. Once you have loaded everything, you can load in all the constraints. You can run the scenario based on the flow constraints for the past, and what you get is the baseline. Now, baseline looks ugly, for the lack of better word, but that is the reality. This is what we saw for one of our customers when they were, they had 3 distribution centers, but when we looked at their flow profile, they were serving all customers from all location, which was very inefficient. And that's how a lot of supply chains look, and people just don't know. So that's why doing a baseline and optimizing baseline is valuable standalone, even if you're not looking futuristic. Once the baseline is done, then as you can see, the baseline cost was 60 million. 6 million was first mile, middle mile cost, and then 53 million was around warehouse to customer cost. So DCs were shipping directly to customer using domestic 2 day, and the average distance from DCs to customers was about 1,000 miles. So pretty significant distance, even with a 3DC network. So then we did unconstrained version of the baseline, that if you were to just flow the product optimally without making any investments in your physical network, you can just do that by optimizing your inventory and regionalizing your service area. So if you do that, this is how the flow profile should look like. And these are the assignments, optimal assignments. Once you throw in the SKUs, it will also tell you how the SKUs should be placed at different DCs in what quantity. And then the cost here, if you can see, scenario one cost dropped from 59 to 48 million. So that's like 10 million decrease just by tweaking some settings. So ton of value. The warehouse to customer distance dropped from 1,000 miles to 600 miles, almost 40% reduction. So this is the value of network analytics and network optimization. And then obviously we built some other scenarios around, introducing hub location, which is cross-dock, as Marcos and Andre mentioned, that you can leverage your parcel provider network more efficiently by having a zone skip program. So zone skipping means that you are building a truckload and of your packages and injecting and sending that truckload directly to the more regional areas. Anyways, FedEx, UPS, USPS, they'll do it if you give your package to them, but they'll charge a fee. So if you do it yourself, you might be able to save a lot of money there as well. And we have analyzed that those savings are also significant. So 49 million from scenario one drops to about 41 million. So 7 million difference. So you do incur some cost sending packages to the hubs, but then you save a lot on last mile. And the last scenario which we did was a very so this one, we mentioned, the delivery speed reduces because you're going first to the hub and then to the end consumer. So it adds a day. So the 2 day becomes 3 day, but then there is cost saving. So we are not saying like this is the great, this is a great model. It's a lower speed model, but not all businesses need that speed. So it really depends what kind of business you are in. If you have captive consumer base and you don't need to serve them at a very high speed and the customers are cost conscious, then maybe this is the right strategy. But if you are in a generic supply chain and you need that speed to increase sales, then maybe some other model works. So it really depends on your business strategy. And this last strategy is how do I get like a 1 day, same day footprint using my micro fulfillment or store network? So this talks about, getting using your 3DC network, getting that flows to these stores and then serving the customers really from these stores. And that has a different cost profile. As you can see, the cost increases slightly in this scenario, and there's going to be inventory impact, which is not which has to be done outside the model because inventory analysis. But for similar cost profile, slightly higher, you can achieve next day service level as well. So that's the that's more or less some of the things you could do with this modeling exercise. There are detailed reports which you can download for each of the model, and these could look like your cost reports between different lanes, your throughput reports, your plant production reports, so on and so forth. Because as a result of these modeling exercise, you need these reports to configure the systems or help with execution of it at a very detailed level. So all those can be done with running these analytics and having it aligned with your business strategy.